Hello, Jermaine here and welcome to this video. So what we're going to be exploring here is the topic of reflections in Dart and how essentially we go about doing it. I know that reflections has been a scary topic for me in particular over the years because it's been difficult to understand, mainly because it's been hard to figure out use cases for it. So in this video, we're going to be covering reflections and learning exactly how we can go about writing software with it. So let's get started. So when we mention reflection, essentially what we are talking about is the ability of a program to examine and modify its structure and behavior during runtime. If that doesn't make sense, not a problem. We're going to explore that right now. So reflections is also made possible in Dart through the Dart mirrors library. So it contains classes and utility functions for essentially doing reflections. So here's a basic example of how reflections work. We will create a class called endpoint, which will have a method called handle. And in here, I'll just print out request received. We'll create our reference to our reflected instance, and then we'll use the one of three methods. So there's reflect class, and there's reflect type. With reflect class, you pass in essentially the class name to be reflected on, and then reflect takes in essentially an object. So in this case will be our instantiated class, and there's a reflect on a type. But for this example, we'll just use reflect. And in most use cases, you probably will be using this method. Okay, so we'll call reflect, and then we will pass it an instance of our endpoint class. And in this case, this reflects returns what's known as an instance mirror. So that's one of the various mirror classes which are part of Dart mirrors. Also, we can learn a bit more about it if we go to the documentation. If we come here, we look at instance mirror. It tells us what it is. It reflects an instance of a Dart language object, which allows us to use these properties. So in here, I'll just print out our reference, our instance mirror dot, let's say the type. And if I save this and then I run bin main.dart, it gives us the result, which our type here is a class mirror on then the name of the class. So again, if you want to also know about class mirrors, it's also in the documentation. If we come back to Dart mirrors and we click on class mirror, a class mirror reflects a Dart language class, and which means that we can use each of these properties. So for example, if I do ref.type dot, let's say instance members, perhaps, save that, let's run that. What does that give us? It gives us essentially the members of our class. So we got the double equals method, we got hash code. These are sort of inbuilt. We got toString, and of course we've got our handle method here. So the way that's represented is as a symbol, and then it takes in a symbol name and then what the symbol is. So that's also another mirror, a method mirror on handle. If you need to understand how these mirrors work, it's all in the Dart documentation. Okay, so for instance here, what we can do is we can do something like this. So because we're reflecting an instance of endpoint, we can do ref.invoke, and invoke will take the name of our member we wish to invoke and any arguments we wish to pass to it. So here we wish to invoke the handle method. So as is seen here, you can literally just do that. Handle method as such, and invoke takes in, if you look at the method signature, it takes in the name of our member, it takes in a list of positional arguments and a map of named arguments. We won't worry about this. We don't need to bother about this either. Since there are no positional arguments, we can just pass in an empty array as such. If I save this and I invoke this, it logs out request received as expected. There's a shorthand as well for handle, but a good use case for doing this approach is, for example, if this is essentially based on input from a user, for instance, or if this is a value that's returned from another operation or from the database or whichever, at least this approach out would allow you to dynamically invoke the correct method, essentially. I mentioned there's a shorthand for symbols, so you can do that, or you could use this approach as well. That would also work. So if I run this again, that logs out request received. Okay, so this is a basic example of it. So let's look at a more interesting use case. In this example here, I've got a basic HTTP server here, and what we're going to do is we're going to be using this endpoint class as a way of dealing with requests that are sent to our HTTP server. And the way we'll approach this is by also combining annotations. So annotations is a way to specify additional information about a piece of code. So what we'll start by doing is creating an annotation called route, and in that we declare our constructor using the const keyword followed by the name of our constructor, and here we'll take a URL which is a string, and we declare a final instance variable called URL. So wherever we pass in here will be assigned to this variable. And to use this annotation, we will come down here to our endpoint, and then right above it we'll use the @ symbol and declare our annotation. So here called route, I'll give it a / value. What I'll do with this is when our request comes to the server, we'll look at the path in our request, and if that path matches this route, then it will invoke the handle method of our endpoint object. So to use that, we'll do something like so. We will create a new reflected object on our endpoint instance by calling the reflect function, and then we'll create an instance of endpoint. So at this point we can find out various bits of information about our reflected object. So we can do ref.type simple name, for instance. Let's try that and see what that gives us. And if I curl to localhost 8085, it gives us the name of the class. But what we are interested in is the metadata attached to this object. So if I save this file, run this again, and I curl, we get an instance mirror on instance of route, which is good because we can now access this route, which is what we want to do. I'll comment these two out, and then I'll have logic along the lines of, we could say I'll create a variable called route annotation, and here we'll say ref.type.metadata, which gives us a list of whichever metadata we've attached, and we'll get the first one, and we'll do .reflect_t, which gives us the actual object from there. And in fact, what I'll do is we'll print out the URL from that, because our reflect_t is this route class, which is got a URL property. So let's try that. I'll kill this, start the file again, run this, and it gives us the URL that we defined here. Okay, and of course, if I am to change that URL and restart this and run this again, then it gives us the URL we defined. Hopefully that makes sense. So I'm gonna come back here. We are going to capture the path of our request. So it'll be rec.uri.path. And then what we'll say is if the path of our request matches the root annotations URL, then we'll go ahead and invoke on our reference, we'll invoke the handle method. I'll pass an empty string for positional arguments. So let's try that, and I'm going to close out the response. I'll save that, and let's give this a go. So if I hit cal 8085, yeah, the URL matches, and therefore it invokes the handle method, which here simply just says request received. Also, I mentioned you're able to pass in positional arguments as well as named arguments. So let's say if this took a positional argument called A and a named argument called B, you could do, if I type this, so string A, and let's say an int B, and let's say we logged these out here. As such, we will now be able to, we can now come in here and pass in our arguments. So argument 1, and then for our named arguments, we'll pass it as a map. We'll pass a map object containing our named arguments, and then we will use a symbol to represent the name of our argument, which is B, and then I just put 2. So let's save this and let's try that. And if I kill this, there we go, got request received, and it logged out our positional argument A and then our named argument B as expected. All right, so let's do something a bit more interesting with this now. We are making an assumption in this implementation, and that assumption is based on the metadata we want. So here we're assuming that the first item in our list of metadata will be this route. But let's say in the scenario whereby we're using several different annotations, then this code will fail because we're referencing the wrong metadata. So let's be a bit smart in the way we go about picking out the metadata we want. And what we can do is, because this returns a list, we can use one of the list methods called first_where. And first_where will take in a test. So for each of our metadata, we want the first_where the metadatas reflect t, so the actual object is of type route. And first_where takes in a second argument, which is a named argument, or else we want to return null. And the reason why we do this bit is if nothing is found, then an exception will get thrown, a bad state error will get thrown. So to protect ourselves, we just do that, which means in the next, afterwards, we can do if route annotation is of type route, and if the path of our request matches the route annotation's URL, we'll wrap it in an expression and we'll say route annotation dot reflect t, the actual object, and we'll cast it to route. That way we can retrieve the URL. So if the path matches the URL defined in our route annotation, we can go ahead and invoke the handle method. So I'll save this and let's give this a go. And if I access the server again, nothing gets logged out, which means, yeah, let's adjust this essentially because route annotation returns an instance mirror. It doesn't return the route type or route object. So we'll do this instead. In fact, this is the right way of doing it. If it's not equal to null and then the path is that, then we'll do that. So let's save and try this again. And there we go. Request received, and as always is logged out these arguments that we passed through. So I've amended the endpoint class by changing the implementation of the handle method, which is a switch based on the request method, which dependent on the value would invoke one of these instance methods here. So of course this works, but then the issue here is that this piece of code is quite extensive and repetitive. As more methods get added, you'd imagine that would incur a new case block and so on and so forth. It might probably make it less readable in the long run, and if there's always an easier way of doing it, then I would recommend taking that approach. So let's see how we can refactor this approach into using annotations. The annotation we're going to use is a custom annotation, and we'll call it route methods. So I'll declare it here called route methods, In fact, I'll make a singular route method, and we need to declare a constructor by the same name, which takes in a string called method. And here we'll define a final property called method. And in fact, I'll do that. So of course, this now means that we're able to do, for example, here in the case of get, we can have route method, and then we'll pass in our method, which is a get. So what this means is that when we make a request to the root path and the request method is a get, then we wish for this method to be invoked. So let's see how we're going to do that. We're going to come back here, and then we're going to change the implementation here, and also remember to pass the request in here as an argument for endpoint, because it's expecting one. Okay, so we'll comment this bit out, because if the URL matches, we also need to check the route method that's used. So the logic would look as such. We'll take our reference, do .type, which gives us a class mirror. All we want is to loop over each of the instance members of our class, which would be, well, let me log it out and let's see what that looks like. Okay, so this is what this gives us. We get these inbuilt ones, but then we get these methods. So we got handle get, handle put, handle delete, and so on and so forth. So what we want to do, we will loop over each of these, which for each of these, we get a symbol for the name representing the name of the instance member, and then the implementation of that. So I don't need the first argument, but we need the second one, so we'll do member. And in here we'll have a check on each of the member. So we'll do a couple of checks before we proceed. So for instance, if the member is an operator, so like this one for instance, we don't want to proceed because that's not what we're looking for. So if the member is an operator, if the member is not a regular method, for instance, and also if the member's owner simple name does not equal endpoint, we won't proceed any further. So just so we see how we get each of these, I'm gonna print them out, and let's log this out. Okay, so for each of our members we get these. So if you notice, logging out member.owner gives us one of two class mirrors. So there's a class mirror on object, which is what we don't want. So for example, it will be toString, for example. So the owner of this toString method will be a class mirror on object, which is because all Dart classes essentially extend a base class called object. So we don't want that. But essentially, we're looping over each of the members, and we want the ones whereby the class mirror, or whereby its owner is our endpoint class, because that means those are the methods we've defined ourselves. So if we come back to this if conditional again, if the member is an operator, we're not going to proceed any further. If it's not a regular method, we won't proceed any further. And if the owner's simple name, if it's equal to object or anything else, then we're not going to proceed any further. So I'll comment this bit out and let's resume. So of course, if we get here, then that means essentially we're working with one of our handle methods. So at this point, let's grab the root method annotation. And what we'll do is similar to before, we'll do member.metadata.firstWhere, and we wish to check that the metadata's reflectee is of type route method. And once we got that, we can get the reflectee out as route method. And once we've got our annotation, that means we can check if our route method's method is the same as the request method, then we go ahead and we will invoke that method. So we'll do ref.invoke, and then we get the member's simple name, and it doesn't take any positional arguments. So let's look at this again. We are looping over each of our instance members of the endpoint object that we created, and we've got some conditions. We'll retrieve the route method information on that method, and then we'll have a check if the method matches the request method, then we'll invoke the method itself. And we know the name of the method by accessing the simple name property. I'll print this out so we know what method is getting invoked. So let's give this a go. Okay, we get bad state, no element. My bad. Let's go and add this in. Do that. If route method is not equal to null and route method as route method.method is equal to request.method, then we'll invoke this. So let's try this again. And I forgot that it's the reflectee that we want. So let's kill this and try again. It's got the correct symbol, got get request. So it's actually working. So let's try that again. Yep, got get request as expected here. So now that we got that, we could do the same for the other methods as such. So then if I stop the server and let's restart the server again. Let's try with a get. Okay, we got get request. Let's try with a post. We got our post request and I think you got a picture, and I'll delete. Okay, so that's good. Which means that now we can get rid of all of this, which now looks much cleaner. So another way we can refactor this even much further is by using named constructors. So rather than passing in these string values, we could essentially define named constructor annotations, which behind the scenes will set the appropriate method. So that looks like this. If we come to our root method class, we'll create another constructor using const, and then it will be .get, which essentially would instantiate the main constructor and then pass in the method we want. So of course we can do the same for post, put and delete, like so. So now we can come here and instead of doing all of that, we can have dot followed by the method. So get post, put, delete, which essentially saves us from passing the string values around. So let's try this. So I'll run our dot file and let's start with our get. Okay, we got our get request, we got our post request, it works with our put, and of course it works with our delete. Alright, so just to recap what we've done so far, essentially the take-home point from this video is to use reflections in Dart. There are several approaches, and a common approach is by the use of annotations for annotating various parts of the code and then using reflections to extract these values, which essentially you could use to dynamically invoke one of several methods. So I hope this video was informative and that you see reflections can be quite powerful if used correctly, especially when combined with annotations. Now this is a pattern that is used for most of the Dart packages out there. So packages like Aqueduct, for instance, if you've seen any of my Aqueduct videos, this should look familiar because it's essentially what they use for marking the appropriate methods. I hope you found this video informative and that you learned something different today. If you really enjoyed it, do hit that like button. If you haven't subscribed yet, do hit the subscribe button and also hit the bell notification icon next to that subscribe button so that you are notified when new content is released. Of course, if you got any feedback, if you got any comments, let me know down below. Thank you.